A cemetery of 40 people with brow ridges thicker than a Homo erectus, and faces that would not look out of place in Java 500,000 years ago. Yet they were buried with ochre and shells, just 9,000 years ago, in the Murray Valley. The cow swamp individuals, excavated between 1968 and 1972 from a dried lake bed in northern Victoria, possess cranial vaults so thick they average 13 millimeters, robust mandibles with a biting force that surpasses any living human population, and receding foreheads that make a Neanderthal profile seem delicate by comparison. The accepted story of human settlement in Australia holds that a single wave of grassal modern Homo sapiens arrived around 50,000 years ago, and that all subsequent variation fell within the range of recent Aboriginal Australians, with no archaic interbreeding or multi-wave replacement. The catalyst for confusion was the initial radiocarbon dating of bone appetite that placed the skeletons at 13,000 to 9,000 years old, a time when humans, everywhere else on the planet, were fully anatomically modern. The logical cascade that followed was deeply uncomfortable. If these dates were correct, then an archaic-looking population had persisted in southeastern Australia for over 30,000 years after the first arrival, which either meant a separate colonization by an earlier human species, or an extreme regional adaptation that re-evolved erectus-like traits, neither of which fit the out-of-Africa replacement model. Alan Thorne argued in the 1970s that the cow swamp people were descendants of Homo erectus from Java, who somehow reached Australia before the sapiens wave, a hypothesis that split the anthropological community and ignited a political firestorm because it implied modern Aboriginal people might not be the direct descendants of the original occupants. The material proof that keeps the controversy alive is locked in casts stored at the Australian National University, CT scans, and geometric morphometrics, published in the Journal of Human Evolution in 2008 by Darren Kernow, confirmed the extreme robusticity is real and not caused by deformation. But the exact explanation remains unresolved. What lingers is the existential tremor that the story of our own species in Australia is far more tangled than any museum display admits, and the bones of cow swamp are a provocation buried in a repatriation agreement. The deeper you push into the timeline, the worse it gets. And a handful of perforated cone shells from a cave in the far southwest push the conceptual violation back to the very first footsteps on the continent. Devil's Lair is a single-chamber limestone cave near Cape Leuven in Western Australia, and its floor preserves 4 meters of continuous human occupation. In the lowest layer, optically stimulated luminescence, dated to 48,000 years ago. Archaeologists pulled out 3 conical shell beads drilled with a sharp stone point and coated in red ochre, alongside polished bone tools shaped from kangaroo fibulae. The status quo of human origins assumed that the first Australians arrived with a minimal flake tool technology, and that symbolic expression, ornamentation, and ritual complexity developed slowly over tens of millennia in response to new environments. The quantified shock is that these beads appear at the absolute base of the human sequence, meaning the people who first sighted the Australian shoreline already strung ornaments and applied ochre with deliberate symbolism before they had even fully settled the continent. The logical cascade forces a complete inversion of the cultural evolution narrative. If cognitive modernity was fully present in the founding population, then the entire ladder-like progression from simple to complex that textbooks depict is an artifact of missing data from tropical coastlines that are now underwater. Richard Roberts and his team applied single-grain optically stimulated luminescence directly to sand grains surrounding the bead layer, producing an age of 48,000 years with an error margin under 2,000, a result published in Australian Archaeology in 2001 and replicated in subsequent excavations. The beads and tools sit in the Western Australian Museum, their drill holes showing clear rotational wear under magnification. Yet, major global documentaries on human origins persistently ignore them in favor of Blombo's Cave in South Africa or European sites. The reflection that crystallizes here is that the birth of art and identity may not belong to any single cradle, but was carried in the minds of the first modern humans wherever they went, and the Australian evidence is the earliest time stamp of that fully formed mind. That same disregard for Australian material that does not fit the global template escalates when you move to the bones of a creature that technically should never have existed, a platypus with the teeth of a placental mammal. In 1984, opal miners at Lightning Ridge pulled a fragment of lower jaw from the Cretaceous strata, 100 million years old, that belonged to Steropodon galmani, a monotreme the size of a small cat. The jaw retained a full battery of sharp, cusped, tribosphenic molars that no living monotreme possesses, a jaw articulation that was still partly reptilian, and a dental complexity that matched Therian mammals, the group that includes placentals and marsupials. The official evolutionary tree holds that monotremes split from the mammal lineage around 160 million years ago, long before the evolution of tribosphenic molars, and that they retained simple or absent teeth as a primitive condition. Steropodon, however, possesses molars with 3 distinct cusps, arranged in a trigonid talonid pattern, which either means tribosphenic teeth evolved twice independently in monotremes and therians, or that the last common ancestor of all mammals already had complex molars and platypuses lost them entirely. The logical cascade rips apart the standard phylogeny. Michael Archer and colleagues published the formal description in Nature in 1985, and could not hide the contradiction. The paper explicitly stated that the tooth morphology challenges the fundamental dichotomy between monotremes and therians. The open-eyes fossil sits in the Australian Museum, accessible for any researcher, and the cusps are unmistakable under a microscope. Yet subsequent mammal textbooks have sidelined Steropodon as an oddity, and no consensus has emerged because integrating it would mean redrawing the family tree of every mammal alive today. The existential unease is that the classification schemes we use to order the natural world are fragile human constructs, and a single fossil from the Australian Cretaceous can reveal that the true evolutionary history is messier and more redundant than we can stomach. And if a toothed platypus is a classificatory bomb, then a jawbone from the Victorian coast is a nuclear warhead aimed at the very definition of what a placental mammal even is. On a wave-cut rock platform at Flat Rocks, Victoria, in 1997, a volunteer named Nicola Barton picked up a tiny jaw fragment from the early Cretaceous sediments, 115 million years old. The specimen, later named Austribosphenops nictos, measures just 6 millimeters, but carries 3 tribosphenic molars, with a wear, pattern, and cusp arrangement that until that moment had been considered the exclusive signature of placental mammals. The scientific consensus for over a century placed the origin of placental mammals in the northern hemisphere, during the late Cretaceous, with the earliest undisputed fossil being a 65-million-year-old animal from North America. Austribosphenops shatters that geography and chronology simultaneously, because here is a placental-grade mammal from the southern supercontinent of Gondwana, at a time when the northern continents were, supposedly, the only theater for tribosphenic evolution. The logical cascade is explosive. If this jaw genuinely belongs to a placental relative, then the placentals originated in the south, pushed their way north, and the entire narrative of mammal diversification that places Asia and North America at the center is a provincial myth based on sampling bias. The counterarguments were immediate. Some paleontologists claimed the tribosphenic pattern evolved convergently in an unrelated Gondwanan lineage called the Australosphenids, a theory designed to quarantine the anomaly. But the paper by Thomas Rich and colleagues, published in Science in 1999, argued that the dental morphology is so specifically placental that convergence strains credulity. The jaw resides in Museum Victoria, and every high-resolution CT scan deepens the mystery rather than resolving it. Because the internal enamel microstructure matches tribosphenic therians, the haunting reflection is that our understanding of our own deepest mammalian roots may be upside down, and the fossils that could prove it are locked in the coastal rocks of a continent that remains profoundly underprospected. That same rock record, just a few million years younger, produced an animal so strange that scientists could not even identify what order it belonged to, and they quietly gave it a nickname that betrays their despair. In the Miocene limestone of Riversla, in northwestern Queensland, a team led by Henk Godthelp extracted a fragment of skull and jaw in 1991 that belonged to Yalkaperidin cohini, immediately nicknamed Thingodonta, the thing with teeth. The molars are unique in the entire fossil record, each tooth shaped like a tiny circular saw, with longitudinal ridges that run the length of the crown, while the incisors are enormous, proclined, and rodent-like. Before Yalkaperidin, marsupial diversity was thought to be cleanly divided into herbivorous, diprotodontians, like kangaroos, carnivorous dasyuromorphins, like quolls, and a handful of insectivorous bandicoots. Here was an animal that fits none of these categories, possessing a dental battery that no functional morphologist can confidently interpret. The leading theories oscillate between crushing hard seeds, slicing through insect chitin, or a feeding strategy that has no modern analog. The fossil layers at Riversla have been radiometrically dated to the early Miocene, around 20 million years old, and multiple specimens of Yalkaperidin have now been recovered from different sites, confirming it was a successful lineage that persisted for millions of years, not a malformed individual. The formal phylogenetic analysis, published in the Journal of Paleontology in 2003, failed to place it within any known marsupial order, leaving it as an isolated enigma outside the tree entirely. The physical fossils sit in the Queensland Museum. Their blade-like molars, visible to anyone who requests a drawer pull. And yet, ylcaparidin has been omitted from virtually every popular summary of marsupial evolution because it resists narrative closure. The cold reflection it offers is that the mammalian family tree is not a tree at all, but a dense, pruned bush, where entire successful orders can vanish without leaving a recognized descendant, and the survivors we see today are merely the statistical lottery winners. That same lottery was rigged by the arrival of a single species. And the next discovery in the countdown is not a body, but a crime scene painted in burnt eggshells across 2,000 kilometers of desert. Scattered across the sandy dunes of the Lake Eyre Basin and the Simpson Desert are thousands of blackened eggshell fragments belonging to Genurnis newtoni, a flightless bird that stood 2 meters tall and weighed 1/4 of a ton. In 2015, a team led by Gifford Miller published an amino acid racemization and optical dating analysis of these shells and revealed that many of them were burned at temperatures exceeding 400 degrees Celsius, a heat signature that cannot be produced by a natural bushfire and exactly matches a cooking hearth. The comfortable extinction narrative for decades maintained that Australia's megafauna disappeared due to a slow aridification that began around 50,000 years ago, long before humans could be blamed. The quantified catalyst in the Miller study is the temporal precision. The burned shells date to 47,000 years ago, coincident with the rapid human dispersal across the interior, and the carbon isotopes within the eggshell proteins indicate that Genurnis was producing eggs right up to the moment of burning. The logical cascade is as grim as it is direct. A single Genurnis egg would have contained over 1 kilogram of protein, and the shell fragments show scorching on one side only, consistent with being placed in hot sand beside a fire while the contents roasted. Multiply that evidence across hundreds of sites, and you have a systematic, continent-wide harvest that erased an entire breeding strategy in a few thousand years. The definitive paper appeared in Nature Communications, but pushback came quickly with alternative interpretations, suggesting magnetic mineral alteration could mimic burning, even though the chemical markers of high-temperature exposure are distinct. The real reason the finding remained sidelined is existential. If the largest bird ever to walk Australia was cooked into extinction, then the entire romanticized vision of indigenous ecological harmony before European contact is a fable. And that is a story many institutions are not willing to endorse. Despite the empirical evidence lying on the desert floor for anyone to pick up, that same uncomfortable fingerprint of human predation reappears far more violently inside a pit cave on the Nullarbor Plain, where the shattered skeletons of 40 marsupial lions tell a story of deliberate eradication. The Thylacoleo Cave lies in the thick limestone karst of the Nullarbor, a vertical entrance that functioned as a natural pitfall trap for thousands of years. When Western Australian Museum paleontologists excavated it in 2002, they recovered the remains of at least 40 individual Thylacoleo carnifex, the largest meditine marsupial that ever existed, an animal with guillotine incisors, a huge disemboweling thumb claw, and a bite force calibrated to crush bone. The status quo had long portrayed Thylacoleo as a solitary forest ambusher that rarely interacted with humans and whose extinction around 25,000 years ago was a consequence of the disappearance of its large prey. What the cave deposit contained was far darker. Many of the long bones were fractured in a spiral pattern that only occurs when fresh bone is twisted and broken. Several skulls exhibited depressed fractures, consistent with a blunt impact, and scanning electron microscopy revealed cut marks on mandibles, where jaw muscles had been filleted away with a sharp stone edge. The radiocarbon dates clustered tightly at 27,000 years ago, and the pollen from the surrounding sediments showed a stable woodland environment with no drought stress. The research was published in Archaeology in Oceania in 2006. But the language was carefully hedged, and the implications were never pushed into the public sphere. The logical cascade is stark. If humans were actively tracking, killing, and dismembering the apex predator of Ice Age Australia, then the extinction was not a passive byproduct of herbivore loss, but a targeted dismantling of the entire trophic pyramid from the top down. The bones are housed in the Western Australian Museum's collection, and a modern forensic re-examination with taphonomic rigor could settle the debate. But the funding and institutional appetite for such a study appear conspicuously absent. The uncomfortable revelation is that our ancestors may have been the most efficient extermination force the continent has ever known, a fact that reaches its most precise chronological expression in the fossil chambers of Narakurdi, where the timeline of death has been measured down to the millennium. Victoria Fossil Cave in the Narakurdi World Heritage Area of South Australia contains a series of sediment pits that have been accumulating animals for 500,000 years. In 2023, a multi-institutional team, led by Frederick Salter, applied a combination of radiocarbon, uraniums, series, and electron spin resonance dating to a dense bone bed in Chamber D that contains 17 species of extinct megafauna, including the giant short-faced kangaroo, Procoptodon, and the 6-meter monitor lizard, Megalonia. The analysis yielded a high-resolution extinction window spanning no more than 2,000 years, centered on 46,000 years ago, a geological heartbeat that precisely matches the arrival of humans at the Magedi B rock shelter in Arnhem Land. Before this study, the prevailing extinction model from the 1990s onward argued for a gradual decline driven by the intensification of the last glacial cycle, a drawn-out drying that supposedly stretched across 5 millennia. The Narakriti data obliterate that gradualist comfort. Species that had weathered multiple previous ice ages and a far more severe glacial maximum, 150,000 years, earlier suddenly vanished in a synchronous collapse that has no climatic parallel, but aligns perfectly with the human expansion. The research was published in quaternary science reviews, using a gold standard cross-validation protocol that leaves little room for chronological ambiguity. Yet the public-facing narrative in museums and media continues to present a balanced debate, because a single-cause anthropogenic extinction would establish an ethical precedent that casts a long shadow over modern conservation policy. The existential conclusion is unavoidable. The Australian megafauna did not fade away. They were swept off the board in an extinction pulse that was over almost as soon as it began, and the longest continuous culture on Earth carries the genetic memory of that erasure. And if that sounds final, the number one discovery on this list pushes the origin of that erasing mind back so far that it rewrites not just Australian history, but the global story of human consciousness itself. A funeral pyre on the shores of a lake that has been dry for 15,000 years. A body laid out, sprinkled with red ochre, burned. The bones then smashed and burned again in a 2-stage ritual that required an understanding of combustion, bone chemistry, and an abstract belief in an afterlife. That is Mungo Man, cremated 42,000 years ago in the Willandra Lakes of western New South Wales. A date that makes this the oldest known cremation on Earth. The scientific consensus, before the Mungo discoveries, held that complex funerary rituals, art, and metaphysical belief systems were late developments that emerged with the agricultural revolution, or at most, in the upper Paleolithic of Europe, a narrative that placed spiritual sophistication comfortably close to the present. The quantified catalyst arrived with the optically stimulated luminescence dating of the burial sand by John Alley's team, published in Nature in 2016. Which pinned the age at 42,000 years, with a high degree of statistical confidence, older than any comparable burial in Africa or Eurasia. The logical cascade forces a complete reversal of the cultural timeline. The first Australians, within a few thousand years of stepping onto a new continent, were already performing multi-stage mortuary rituals that imply a fully developed cosmology, a concept of the self beyond death, and a technical knowledge of fire manipulation that matches any later human group. The physical remains were repatriated and reburied, but the sediment blocks and detailed stratigraphic records preserved at the site provide permanent material proof. The existential shockwave is that human cognitive completeness is not a recent acquisition but an innate property of our species. And the reason we see a staggered emergence of art and ritual in the Northern Hemisphere is simply that the evidence was lost to the Ice Age, while Australia preserved it. The burial of Mungo Man should not exist, according to the old story. But it does, and its quiet persistence in the red sand demands that we rewrite the opening chapter of the human mind.